Grade 9's another day, another function, more straight lines, and we are looking at, given these functions, now these are in standard form, so now what you were just doing was changing it to standard form. You've given it standard form, and I want you to work out two things. Firstly, what is the gradient of the function, and what is the y-intercept? And we're going to work our way through this. So this video may be a little bit longer, but then that's fine because it's working through it as opposed to just, here we go, have you got it? We're really working through concepts here. So y equals 2x minus 5. And I say, what's the gradient of this function? Now I could tell you it straight off by looking at it. And maybe you're getting there, but we don't yet know why. So I've said use sketches and or a table. Let's use a sketch. So pause, try and sketch the function. Okay, so I'm just going to trust that you've at least given this a go to sketch it, x, y axes. There we go. Maybe that's what you need as your starting point. Pause so you can give it a go now. Right, now the first thing that I find useful is I want to find out where it's cutting the axes. Remember our idea was let's just find let's find 2 points, join them together and make our line. And you can see I already know it's going to go like this. So I'm going to start with the y-intercept. So for the y-intercept, which I know is down there, but you don't know if it's there, or high above, I'm going to say, how do we work out the y-intercept? And that is one thing to find out. We know that the y-intercept is going to say 0 and something. So we know that the x value is 0 and we're trying to find the y value. Easy enough. And I've completely covered up this graph, so that's no good. Okay, so there we are. Things looking a bit better. So we know that the x value is 0 and we need to find the y value. Well, then we just look at our equation and we say the y value we don't know, but the x value we do know is 0, so we're going to substitute. And this is our word all the time. We're just going to substitute and get our y value as minus 5. Therefore, we know that when x is 0, y is minus 5. So we figured that out. Let's put that in the graph, 0, minus 5. Now, please, when you see it, other people that may be putting just minus 5 on the axis, it's not technically wrong just to write. So what I mean is some people might just write minus 5 over there. I really think it is much better to write out the full coordinates all the time. Really, really just helps, and knowing that x is 0, y is minus 5, it's a coordinate, it's an ordered pair, not just one number. Okay. Now we want to work out what the x-intercept is. So by the way, we've just answered the first part of the question. What's the y-intercept? There it is. This bit here is our y-intercept. Okay. Now I want to find the x-intercept so that I can draw the line and we can then find its gradient. So for this point here, we know that the y value is 0. We know that we haven't gone up or down. That point's sitting on the axis, on the x-axis, so it's 0. So determine, let's throw in a good question here. What is the x-intercept? Now you're going to have to actually try and choose a number. Okay, so if we weren't quite sure, our equation was y equals 2x minus 5. We know what y is in this case. It's 0. There it is. 0. So maybe we could do this. How about this? This bit we're going to write as 0. So we know that's 0. And then do the rest of the equation. 2x minus 5. And we solve our equation. So we're going to go plus 5 plus 5. So we've got 5 equals 2x. Okay, if we just want x, so what do we need to do? Let's divide that by 2, divide by 2. So x is 5 over 2. So in other words, what we find is when x is 5 over 2, y is 0. So we can put that in and we can sketch our graph. That should go through those 2 points, right? There, very straight line. And let's label it y equals 2x minus 5. We haven't answered the first part of the question though. What is the gradient of this function? Now, what did we say gradient was? We said for every one step we move across, how far up are we going? So we looked at this in terms of a ratio, and I really like that question of can we look at it like that to say, well, we're going across, in this case, from 0 to 5 over 2. So our gradient saying it's rise over run. So we're going across by 5 over 2. And we're going up. So we're going across by 5 over 2. We're going up from minus 5 to 0. So we're going up 5. Okay. That's not too scary. We've got a calculator which tells us that, here's my calculator here, 5 divided by 5 over 2 gives me 2. Okay. So this is 5. So for every one step we go across, we're going up by 2. Okay, now here's something to look at. Our gradient we said is 2. And here's our original function. Is there 2 hiding there somewhere? Our y-intercept is given as 0 minus 5. Do you see a minus 5 hiding there somewhere? Okay, so we could just answer these straight up without all of this work. Let's look at the next example. So for this one, what do you think the y-intercept is going to be? 0 something. Question 1. Question 2. What do you think the gradient of this function is? Okay, so you've put your guesses in, interested to see what they are. Let's see if we can work out the y-intercept. Y-intercept, we know that the x value is 0, so we're just going to substitute that into our equation. So y equals minus 3x plus 10. We don't know why. Minus 3 times our x value is 0 plus 10. Hey, look at this. Minus 3 times 0 is 0. 0 plus 10 gives us 10. So therefore, 0, 10, there's our y-intercept. Hey, look at that. There was a plus 10, and there's a plus 10 as well. Okay, gradient. Let's look at gradient in this way. All we need is 2 points, 2 inputs. So we're going to draw a table here. So please draw the table, because we're not just looking at, oh, what's the answer, but we're developing quite a few concepts here at the same time. So let's choose 2 x-intercepts, x inputs that are 1 apart. So I'm going to put 1 and 2. So for every one step across, how far up do we go? And that's going to be our gradient. That's our gradient. In fact, I think that's so important. Let's just reinforce this. Gradient for every one step across, how far up do we rise? Okay, so we got that. Well, we're just going to have to see what the difference between these two outputs is. Cool, let's do our first one. If we input 1, let's do it over here. Y equals minus 3, 1 plus 10 equals, what does it equal? Okay, so when we input 1, our output 7. Keeping on reinforcing, input, output. So when we input 1, we output 7. Second input, if we input 2, what's our output going to be? Minus 3 times 2 is minus 6 plus 10 gives you 4. So when we input 2, our output's 4. So for every one step that you go across, so we've gone plus 1. How much have we gone up? We've risen by minus 3. But we could have told that right at the beginning, because there it is, minus 3. So there's our gradient given to us, but just reinforced with for every one step we go along, we're going up by minus 3. In other words, we're going down by 3, but we're going to call that minus 3. Okay. Last question, because these are your questions, these 4 that you're going to have to do really by yourself. And this last one says y equals 4x minus 3. What is the y-intercept of this graph? We know the x is 0. Yeah, in fact, let's just look at it. There it is, minus 3. Done. What is the gradient, which starts with m, of our graph? 4. There it is, 4. And we know this from our standard form, which you were doing before. All graphs, straight line functions, we can write as y equals mx plus c. This is going to tell us our gradient, and our y-intercept is always going to be at 0, c. But we can always substitute to find it out. So now for something a little bit different, I want you to sketch the following lines and think about what their gradient is at the same time. So sketch the following lines, and let's add that in and determine their respective gradients. There we go, beautiful. These lines are going to look a little bit different, but as your starting point, x, y, and I want you to sketch your line on there. So what does it look like? Does it look like that, whatever it looks like? That's what you need to sketch, and do it for each of these. And when we meet, we're going to see what those look like. So we're meeting on Thursday. This is your work for Wednesday, and we can re-look at what was happening in these functions. Have the best of days.